All right, everybody. We are in section 2.6 in the book, and we're going to work on proving angles congruent. So we're going to start out with proving some theorems. So once we prove these theorems, we'll be able to use them, and it'll also help us to familiarize ourselves with the two-column proof process as well. All right, so theorem 2.1 or 2-1, vertical angles theorem. So we're trying to prove that vertical angles are congruent. So if we're given this diagram here, we have two lines intersecting. Angles 1 and angle 2 are vertical angles, and so we're trying to prove that they're congruent to each other. Okay, so we're going to start out with our given. We're given that we have a vertical pair here, right? Angle 1 and angle 2 are vertical angles, right? Okay, and the reason is given. All right, so let's see what we can deduce from the picture here. So we see that angle 1 and angle 3 form a linear pair, right? So if they form a linear pair, that means they must be supplementary, right? So angle 1 and angle 3 are supplementary. And the reason why is because angles that form a linear pair are supplementary. So that's the linear pair postulate. But you could also just, if you forget the name of the postulate, which you'll have your cards with you, but if you forget the name, you can just say because angles that form a linear pair are supplementary. So you don't necessarily have to name the postulate. You can say what the postulate means, or explain the postulate in words if you forget the name of it. All right, so what else do we know is supplementary here? And that's right, yeah, angles 2 and 3 as well form linear pairs, so therefore they're supplementary, right? So angle 2 and angle 3 are supplementary for the same reason. Okay, so we'll just keep this the same step 2, so we don't have to rewrite the reason there. All right, so step 3. So supplementary means they add up to 180, right? So we can say that angle 1 plus angle, or let me put the measure of there, the measure of angle 1 plus the measure of angle 3 equals 180, right? And the same thing with the measure of angle 2 and the measure of angle 3 equal 180. And the reason why is definition of supplementary angles, right? Supplementary angles add up to 180. So I'm just going to put definition of supplementary angles. Okay? All right, once again, you can just explain and say, well, supplementary angles add up to 180. All right, so now that we have that, we can say that, well, this, since this and this equal 180, right? Since they equal the same thing, they must be equal to each other, right? So we can say that the measure of angle 1 plus the measure of angle 3 must equal the measure of angle 2 plus the measure of angle 3. All right, and we can say that by, you could use substitution or the transitive property. I'm going to use the transitive property. Right? If two different things equal the same thing, they must equal each other, right? Transitive property of equality. So now what we can do is we see that the measure of angle 3 appears on both sides, so we can subtract that from both sides, right? We can basically cancel that out, and we can say that, okay, well, the measure of angle 1 has to equal the measure of angle 2, right? by subtracting out the measure of angle 3 from both sides. And so that's a subtraction property of equality, right? Oops. Subtraction. Okay. So since the measure of angle 1 is equal to the measure of angle 2, angle 1 must be congruent with angle 2 because angles with the same measure are congruent, right? So you could say definition of congruent angles. I'm just going to write out angles with the same measure are congruent. All right. So we just got to our final statement, right? We got to our point B, our endpoint, and so we proved that vertical angles are congruent.